Yeah, hello everybody to our statistics lecture. Before we start, an announcement. I have a talk organized at the 7th of November, 8:15, and if it's technically possible, this will also be online, and this will be about investment decisions and the business cycle, and more detailed information about this talk will come in the next days. So hopefully you find this interesting and then you can join. And as I said, more detailed information in the next days. Okay, yeah, we have finished the, so to speak, introduction of our course, that we again know what is a random variable, what is the distribution, and how can we describe a distribution. And now we will start with a more specific part of this lecture. And for this, we want to deal with so-called inequality matrix. And yeah, inequality matrix we have maybe already described when we looked at, for example, the variance, because in general we would have a distribution like this. Maybe this could be symmetric, but also this could also be, or not like this. Oops. Something like this, so to speak, unsymmetric. This, oops, distributions. There we have also already looked at one possibility to describe this when we introduced the skewness, if you remember. And now we want to have a look in more detail in describing these unequal distribution. And especially if we look, for example, at income statistic in countries, then this is also a great question if we want to qualify something like a good distribution of national income in a society. Then we see that, of course, we have more poor people in a society than rich people. And so maybe we can say that in society we have maybe that the 10% poorest people receive only 1% of the national income. And on the other way, and this is then the unequalness in our society, that maybe only 10% of the population, that they receive 25% of national income. And therefore, we would talk about a quite uneven distribution. And we will see that, of course, also in modern societies, we have these skewed distributions here and how to describe and how to deal with them. This we will do in this part of the lecture. And of course, these unevenness we can also identify if we look at markets, and especially if we look at market forms from polypole to oligopole until a monopole. When we look which enterprises are in a specific market, then in a polypole mostly we have many small companies, and this will correspond then more for an equal distribution. And if we then move on to the right, first to an oligopole structure and then to a monopole structure, then we have more and more concentration in our market. And for this, of course, we could have a look at the market share of the companies. In a market. And this is then this share, of course, one of the first methods to describe, for example, the market structure due to an unequalness. And to define this in an abstract way, we call this the so-called concentration ratio. So definition is the concentration ratio CR is the sum of the percentage of market shares of a pre-specified number of the largest firms in our market. And if we have a very concentrated market, such as an oligopoly structure, then maybe the market share is more or less concentrated, for example, at the 3 largest firms, that they have, for example, 90% of the market share. So if we calculate this, then of course we can have a look just only at the largest firm, and this is defined then as CR1. So X1 with index 1 is only the largest firm, and of course, what is the market share of this firm? This is then just X1 over S1, and then we start with the second largest, the third largest, fourth largest, and so on. And for this, of course, we just add up the market shares or revenues of these smaller firms. So we define them, for example, CR2 as X1 plus X2 over S1, and X1 is then the largest firm and X2 is the second largest firm, and so on. So CRK is then X1 to XK over Sn, and Sn is the total revenue in our market. So this is then, of course, maybe the most simple way to describe how concentrated a market is. But of course, we have other indicators to describe this, and another indicator which was introduced, I think, in the 1950s, 1970s. And this is the so-called Herfindahl index. And what we do here, this corresponds, somehow with, aggregate numbers we take in statistics that we, in this case, do not add up every market share of our single firms, but we add up the squared market shares. So the Herfindahl index is then just defined as the sum of the squared market shares, and these squared market shares, this we already had from our concentration ratio. So this is then, of course, also our number Sn from the former slide. And since we add up these market shares, then of course it is then the case if all firms are equal, then and have the same market share, then of course we end up with an Herfindahl index of 1 over n. And of course, if we have a monopole, only one large firm in our market, then the square of 1 is of course 1, and therefore the maximum value of hi is then equal to 1. So, and why do we do this? Well, what does this squaring means? Squaring means that larger firms have a higher weight in this Herfindahl index than in the concentration ratio. And we can easily use this if we just write this sum in another way. That we write I from 1 to m is ai times ai. So this is then of course our market share. And how can we interpret then the other ai? The other ai can then more or less interpret it as the weight of the firm I. Well, and then of course, the larger the firm, the larger is their market share, and therefore this market share is, so to speak, weighted with itself, and therefore we can interpret these Herfindahl index as a number which overweights the larger firms. Well, and this we do quite often in statistics, that we can say compare this covariance that we squared our numbers for example with the variance. And what have we done using the variance? Using the variance, we just calculated the squared deviations from our mean. So this was just the squared deviation from the mean. So squaring distances, this is what we use very often in statistics, and actually this Herfindahl index is quite often used in order to describe the concentration in portfolio investment in capital markets, for example. So this measure is often used to describe the concentration in investment portfolio in capital markets. So my question is, maybe you have used this measure already in your lectures on investment or something like this, when you had a look at capital market. Has anybody already heard about the Herfindahl index? Because in capital market, this is maybe the most used measure of concentration. Anybody heard of this? So maybe not. Okay. Then you have learned something new. So especially if you look, for example, at a stock market index like the Dow Jones or the DAX, then of course you can ask, what is the concentration of single firms within these DAX? Is it more equally distributed or unequal? And then you just add up the market shares of the single firms in the DAX, and then you have a measure if this Herfindahl index is in the neighborhood of 1, then you know that your index is mostly driven by one or single firms, a few single firms, and if it is in the neighborhood of 1/n, then you have a more equal distribution of the firms within some index. So also, when do we use this Herfindahl index? Especially if, in our modern Western societies, we want to have mostly a framework of perfect competition. And in order to have these perfect competition, we don't want to have oligopole or monopole structures. And then if our authorities look at a market, then they have to describe these markets in order to analyze this market. Do we have there something like an oligopole structure? How far we away from perfect competition? And especially if you have fusions in the market, that a large firm want to acquire two smaller firms, so you have your classical mergers and acquisitions process. And if you want to allow, or you ask yourself as antitrust authorities, should we allow in this market these mergers and acquisitions? Do we still have then a situation in the neighborhood of perfect competitions? Then these authorities also look quite often at the Herfindahl index. And then there is also a quite nice example. Maybe you know the example of Cournot competition. I think in other lectures you have done Cournot oligopole. You have heard what is understood by Cournot oligopole. There you have just two firms taking the produced quantity of the other firm as given. And then you had your oligopole outcome, and this oligopole outcome is then also matching your prisoner's dilemma, for example. Well, and this Cournot competition, where one firm is maximizing its profit given the quantities of the other firms are fixed. This, of course, we can analyze not only for two firms, we can analyze with also three, four, and especially also n firms. And then the outcome of the demand is elasticities in this market, in this competition process. This can also then defined or identified with the Herfindahl index, and this we will show in an exercise. Then maybe, if you make some case studies or something like this, then also in the market research, this Herfindahl index is quite often used when you want to interpret, do we have high customer loyalty in my market, or are my customers quite often switch the companies where they are buying their products. So if you maybe in your bachelor thesis or something else, you want to calculate something like where you want to describe your market structure, then also this Herfindahl index is quite often used. And maybe a quite actual example is that this Herfindahl index is quite often used in politics. We had just our poll here in our nice little country almost 10 days ago, and then we have chosen our parliament and our parties, and then we can also ask, do we have there a very concentrated structure in our new party system after the polls, or is it more equally distributed? And there the Herfindahl index is then interpreted as the so-called effective number of parties. So this Herfindahl index has a very wide range of applications. Okay, then we have defined our two measures, and then we want to start also with some example, and these I also want to do again in Excel with you, that these are our numbers, that we have three different situations, A, B, C, and D. And especially if you have a look here at example C, what kind of market structure do we have here? I think this, with a short look, we can already answer. What kind of market structure do we have here? Oh, so these are the firms. So we have from 1, 2, 3, 4, 5, 6, and then in the example D, we have 10 firms. And the total revenue of this firm here in example C should be 1,000, and all other firms should be very small, that we almost cannot count them. So what kind of market structure do we have then? If the total revenue in this market we have only one firm, then oligopoly, I think even more, or well, these zeros here we can interpret, maybe there are firms, but they are so small that in the second, fourth digit there we would have, yes, of course. So this would be, of course, then a monopoly. And so we take this example here, A, B, C, and D, and we want to calculate, not equally signs, but we want to calculate just these three concentration ratios, C1, C2, and C3, and our Herfindahl index. So then we take our numbers here. This we can copy, and let's take a new table. And a bit smaller. $90 more. 80 and even 70. Because then I think you can see everything almost. To put it like this. So what do we have to do if we want to calculate for A, B, C, and D? At first, or let's take it down here. If we want to calculate CR1, CR2, and CR3. And also, oops, percentile. No. R3. Becoming larger, I don't know. Let's 80. So now we can have a better look at it. So what do we have to do in order to calculate, for example, 1 concentration ratio 1? How did we define this? Let's go back here. Concentration ratio was just revenue of the largest firm divided by the total revenue. So what do I have to do here? I think it's not that difficult. Any idea? Yep. And how do I get then the number for the concentration ratio 1? So here we have the largest firm. And what do I have to do with this number 370? Because here I have to calculate a number. Well, I think at first I just need the total market share, the total revenue in our market. And for this, I have to just sum up all the revenues within our example A. So I have 1,000, and then what would be CR1? . Yes. So just 0.37. And CR2, the two largest firms, the market share. What do I have to do? Only 250. We have a look in our definition. So the next one, CR2. Here, CR2 is the sum of the revenues of the two largest firms divided by the total size of our market. Yes, so we have to just sum up, oops, these two numbers where we are. Oh, do not need. Now we are at the right one. So we sum up 250 plus 370 divided again by the largest firm is then 0.62, and very difficult CR3 would be yes to our other two numbers, and of course then we have sum all these three divided by total market share. So, and of course, we have to do the same for our other examples. So at first, we have, of course, to calculate our total market size. And in our example, this is always 1,000, because here I have 10 firms and then I have to go up here to 11. Then I have the total column, and this is also 1,000. And in this case, in example B, of course, there I have this equal distribution that every firm has the same size, and therefore I just start with 200, 400, and then 600, and again I can just copy these numbers on the right. And for our monopole example, then of course I have only one single firm with representing the total market, and therefore of course I can only calculate CR1. So copying this here, we have our 1, and since we have a monopole, No, no, this is not possible. So then I at first have to reformat this. Text. And now I should write this. And in this case, what do we have to do here? What is CR1 in case D? Market share of the largest firm. I think it's not that difficult. So just 200. Oops. Equals 200 divided by 1000. And the second one, since our firms in their market shares are already ordered from large to small, then we can also write down this sum is 2 times 200 divided by 1000. And the last one, sum of 3 largest firms divided by 1000. And now we want to calculate the Herfindahl index, which is just the sum of the squared sum of all market shares. And for this, of course, we first have to calculate the market shares. And the market shares of all single firms. What do I have to do then in example A? What is the market share of firm A? It's too early this morning. If I have a total market size of 1000 and the revenue of the first firm is 70, then I think the market share of firm 1 in example A is 0.07. So, and then for the Herfindahl index, in the second step, we have to square this. So the market share is then 70 divided by 1000. And since we want to do this with all our single firms, we have to fix the 1000 again. So if you have a look here, then you need this dollar sign in front of the 13. And then we can go downward here. This we can do for B and C. And for D, of course, we have to move our formula down to 10. Let's make this a bit larger. So this would be all our market shares. Or you can see this. On 4 cells. And then we need the square market shares. So we always have to square all these numbers. So 0.7 squared. And this we have to do with all our numbers. And here we have 10 firms. And then we have to sum these square numbers. So this one, this one, this one, and this one. And these are then the Herfindahl indices of our 4 examples. Let's move them down here. And then we are done. So let's take these, all our calculations, and let's start to interpret these numbers. I think this is enough. If we copy this one. So if we have a look what we have done here in this example of our concentration ratio. So in our first example, CR1 equals 0.37. This means the largest firm has a market share larger 1/3, and therefore, so 30% or something like this is, if you look at a concentration ratio, identified with a quite large number, and therefore you would call this a quite concentrated market. In this case, especially since CR3, CR2, and CR1 just add up from 0.2, 0.4, 0.6, always with the same amount. We have that every market share of every firm has the same size. Every firm has the same market share of 20%. So every single firm is quite large, but not larger than another firm. So you have an equal, of course, distribution, but since 20% is quite large, then you have more or less an oligopoly. Structure in case C, of course, this we have already said. There you have a classical monopole, since one firm totally represents the market. And in case D, of course, yeah, you have CR1 is 20%. So you have there, yeah, some concentration in your market. But then if you see compared to the example A, there CR1, CR2 and CR3 even adds up to almost 80%. And here CR3 is only 55%, so quite smaller than in case A. So you would say it is quite concentrated, but not that concentrated as in case A, since CR3 of D is 0.55, and this is much smaller than CR3 of A, which is 0.81. And here you see also that it is that if you analyze the market via these concentration ratios, that you shouldn't look only at one number, CR1 or CR3, because from CR3 you obtain here your concentration, and also if you look at example B, if you have a look only at the concentration ratio A, CR1, then we have here 2 times the same numbers, but also in this case we have 0.55 is smaller than 0.6. That you have a more competitive market in case D than in case B. So we write this down also. Not that concentrated as in case A, and case B, since this we have is smaller than CR3 and B, which was 0.6. So although in this case you have an equal distribution, but since you have less firms than in the other market, we would say that this market D is not that concentrated as the market B. And this also we see in a good manner then if we look at the Herfindahl index, because then, of course, here we have this classical outcome of 1 if we have a monopole, but the Herfindahl index of market D is much, much smaller than the Herfindahl index of the examples A and B. So HI of D is much smaller than HI of A and B, and this would then mean that market D is much more competitive than A and B. And there you see also this additional information which you have in this Herfindahl index, because if you, for example, compare only market B and C with the concentration ratio, then we see, well, they differ here a little bit, but not very much. But if you have a look at the Herfindahl index, then you have here a number of 0.045, and here you have this number of 0.2. And therefore you see that we are, in this case, much, much smaller than in this case. So we can interpret that this market D is much more competitive. So by 3 and this here. Okay. So this is then a first possibility to analyze a simple way the market structure and looking at an equal or unequal distribution of our market shares. So then we will start today with another concept. And maybe you have already seen this in your introductory courses. And this is the so-called Lorentz curve. Question, has somebody of you already heard about the Lorentz curve? So Lorentz was an economist in the 20th century, and he especially looked at income distributions. And he asked the question, well, how can I describe in a quite visual manner the equalness or unequalness of the national income distribution in a society? So especially he looked at these statements we had today in the beginning, when we said that, for example, the poorest 10% only receive 1% of the total income. Well, how can I visualize such a statement? And for this, he developed this concept of a so-called probability plot. And what is this probability plot? Well, then on the horizontal axis, I just write down the proportion of our society. So 10% of our population. So I would write down 10% at the horizontal axis. They have 1% of the total income. So this proportion on the vertical axis. So my first point would then be 10% horizontal and 1% on the vertical axis. And then we move on to the 20% poorest people in our society, and maybe these, since the next 10% are a bit richer than the poorest 10%, maybe their national income then adds up to, let's say, 5%. So the next data point would be then 5%, and we move up to 20%, and we move in the vertical direction up to 5%. And of course, if we have a society with a very uneven distribution, that we have only a very small number of rich people in our distribution, and let's say only 4 or 5 people, as compared to our monopole example, that they have almost the total income in a society, then the first numbers would be really, really small. And then at the end, on the right side, we would move up within our Lorenz curve. And so we can interpret if our Lorenz curve is quite away from the state line of the uniform distribution, the more we are away from this uniform distribution, the more uneven is the distribution of national income in our society. And this we will look in a minute also graphically. So the Lorenz curve is then a graphical representation of the relative concentration of income, or in general, of course, we can do this also with our market share examples we had already of a variable in general. And then we have to define how we calculate these Lorenz curve. Of course, we look at first at the poorest people in our society. Then we have at first, of course, again, sort our data in this ascending row. This also we had already done when we looked at the median, or of course, when we calculated our concentration ratios. If we have this ascending row, then we come from the poorest to the richest. So we calculate at first the total sum of all our incomes. This would be then total market size or total income. This we need then also, we want to compare this with just the number of our people or the number of our firms in our market. So we have to calculate then the cumulated relative distribution. So we look, for example, at the 5 poorest people in our society, and in our society should maybe live 100 people. Then we divide 5 by 100. And then we ask what is their proportion of the total income. So we look again at our ascending row. We sum up all these maybe 5 poorest people in our society and divide their income by the total income of the society. Or we take the 5 smallest firms in a market and divide this by the total market size. So this is then, of course, nothing else than our concentration ratio. So, and then the Lorentz curve is nothing else to put these two numbers, Fi and Gi, together. On the horizontal axis, we start with our uniform distribution. We just write down the 5 smallest firms, the 5 poorest people would be then our F1. If we have 100 people in total in our society, this would be 5%. How much do they earn? What is their total income? So the first data point is then FIGI and so on. And in the end, of course, we are at the total market size and the total number of our firms for the whole population and total national income. So of course, then we end up at the point 1, 1. So this is the definition. And then of course, we want to do just one example in order to represent this in our Lorentz curve. For this, we go again to our Excel file. So this was CR and Lavender. And now we want to calculate our Lorentz curve. So how do we get Fi? Go in our definition. Fi was just after we have sorted our people or our firms in this ascending row, and then we take the number of our firm divided by the total number of all firms. So in this case, what do I have to do here in order to get the first data point for Fi? So I have one firm and the smallest firm, and I have a total number of 5. So we obtain 1 divided by 5. And this again, I have to fix at 7. So we start at 0.2. And then the uniform distribution, this would then mean that we go up to 0.4, 0.6, 0.8, and 1. This is, of course, always the same because this is always the uniform distribution, just the number of the smallest or largest firms divided by the total number. What is more interesting is our GIs. How do I get them? So here I mentioned just this is nothing else than the concentration ratio. So we have to do what we have already done some minutes ago. So this would be then our market share of the smallest firm divided by total market share. And in order to use the formulas, we start here with 70 until 70. And if we go on, we want to fix the first cell. Therefore, we have to write our dollar divided by total market size, this 1000, and here again, this cell has to be fixed. Divided by 8. We go down here. And now we want to represent this in a graphical way. So our Lorentz curve would be then the plot of AIGI, and this can be done in Excel via the following possibility. We take our XY diagram, and since we want to have lines, we use this one. And now we have to have a look if it's on the axis right. Yes, we see. So we are moving up here. From 0. From 0, 0 to 0.2, the first one, 0.4, 0.6, 0.8, and 1. And here we move up, and you see this is the data point 0.2, 0.07. So, and since we want to interpret this curve, we compare this quite often with a totally equal distribution in a country or in a market. And if all firms would have the same market share, then of course we would have here also a 0.2, 0.4, 0.6, and 0.8. So we also want to show these straight line, the 45-degree line within this diagram, and this we can put in if we take just the FIs as both data points. So we put in then for X these data points, and for Y these data points. Oops, not showing. not 2 times C? This one and this one. Okay, and then fix also this. Here we can go to also leave this. Here you can fix the axis to 1 and this axis also to 1. Then it looks a bit nicer. And let's take also title. And let's name this Lorentz curve. Okay, so we put this in here. And then you have these Lorentz curve here. And well, here also you see that it is the Lorentz curve is quite in the neighborhood of 45-degree line. And therefore, yeah, you have quite a concentration, but it is not very large, this concentration in your market compared to your uniform distribution. But you have to be careful, since we have only 5 firms. We of course have here a structure which is quite an oligopoly structure, with even a quite large firm which almost has a market share of 40%. But then the more the Lorentz curve is here on the right compared to the equal distribution, the more unequal is our distribution. So this then, and I think on Thursday we meet again. No, on Wednesday we will of course then do with our other 4 examples, and this is then homework. Then we have B to B is homework. So thank you very much for today. And let's see on Wednesday.